For regular videos on ancient cultures and forgotten civilizations, please subscribe. I've been making videos for this channel since 2019, and from the very beginning, I've looked into evidence presented by those who wish to establish that there existed a lost advanced civilization in the last ice age that was destroyed in a worldwide cataclysm. Because my area of interest and expertise is in ancient historical times, beginning with the advent of writing around 5,000 years ago, I've focused chiefly on the evidence relating to ancient artifacts and archaeological sites commonly dating to that time. But I've received countless requests for me to consider evidence relating to what is commonly called the Younger Dryas Impact Hypothesis, abbreviated YDIH, which is used by many, if not most, proponents for the existence of a lost advanced civilization as evidence for the cataclysm that they believe destroyed it. I've avoided getting into it because this is a huge and complex topic that is outside of my own field. And to be honest, evidence for a cataclysm is not evidence for a lost advanced civilization. It doesn't change the dates of ancient artifacts, so it really hasn't been a priority. But I'm a curious fellow, and the repeated entreaties that I do a video about it finally persuaded me to wade into the waters and look into the subject more deeply. So I have contacted various experts in the fields relating to this question to get their thoughts on the matter, so that I can determine whether there is something to this hypothesis. This video is about this research. It's a long one, but if you're interested in matters relating to this proposed cataclysm, stick around. Welcome to the Myths of Ancient History series, in which I examine widely believed misinformation about ancient history on the internet and in popular literature. Does the Younger Dryas Impact Hypothesis fall into that category? Is this impact a myth? Well, most subject experts seem to think it is. They haven't found the hypothesis persuasive, and I wanted to find out why. Do they have good reasons? Or are they just resistant to new ideas? Let's dig in. I guess we should start by going over some of the key concepts involved here. What is the Younger Dryas? It's a period of time in the Earth's geologic history, and it ran from about 12,900 to 11,700 years ago. Or I should say, years before present, BP. In scientific terms, before present means before the year 1950. The Younger Dryas is notable because it was a colder period than what had come before or after. It began with a relatively fast cooling and ended with a relatively fast warming. But this happened only in the northern hemisphere. In the southern hemisphere, warming occurred. It's interesting because in the preceding time period, the opposite was occurring. The northern hemisphere had been warming while the southern had been cooling. But from what I understand, this seesaw effect is natural. However, the Younger Dryas Impact Hypothesis, YDIH, proposes that at the beginning of the Younger Dryas period, there was a cosmic event of some kind. The exact kind of event has changed in the papers over time, but the current view is that a giant, equal or greater to 100-kilometer diameter comet entered an Earth-crossing orbit in the inner solar system and began a cascade of disintegrations. Numerous cometary fragments from the debris stream entered Earth's atmosphere about 12,800 years ago, and detonated above and or collided with land, ice sheets, and oceans across at least 4 continents in the northern and southern hemispheres. These are proposed to have triggered extensive wildfires as well as massive flooding sufficient to alter major ocean currents, leading ultimately to the Younger Dryas cooling, many megafaunal extinctions, and significant changes to human populations and cultures. As you might imagine, alternative history enthusiasts who believe in a lost advanced civilization have latched onto this theory. And indeed, several of the people contributing to the papers on the YDIH are sympathetic to alternative history. You see, if a mass extinction event occurred, then we have an explanation for why there is no archaeological proof that the lost advanced civilization existed. Mind you, the theory doesn't fit perfectly with their ideas. For example, the YDIH does not propose that there was a single mass extinction event, but rather that there was a ripple effect that caused mass extinctions over time during the Younger Dryas period. The ancient myths about a great flood that we find in some cultures, which occurred in one day, or in 1 month, or in 1 year, according to the stories, which alt history proponents want to associate with the YDIH, do not line up that well with a ripple effect. When these myths provide dates for the event, these also do not line up. So, for example, Plato's date for the destruction of Atlantis is 1,000 years after the date for the impact event. So alt history proponents have to fudge a bit to make it work.
And that's why it's ancient apocalypse, because we know that there was a global cataclysm, a slow one, 1,200 years long, between 12,800 and 11,600 years ago, called the Younger Dryas.
That's a 1,200-year gap.
Göbekli
kind of a slow catastrophe.
Well, no. Göbekli Tepe, to be very clear about the Younger Dryas, one of the puzzling things about it is that you have cataclysm at the beginning, and this global temperature slump is surely cataclysmic by any standards, and you have cataclysm at the end. You have a massive spike, a huge increase in global temperatures, and you have meltwater pulse 1b. You have a lot of water going into the ocean at that time. So both ends of the Younger Dryas are cataclysmic, and it's at the recent end of the Younger Dryas, 11,600 years ago, that we see Göbekli Tepe mysteriously popping up. The focus of the science has been on 12,800 years ago, but there's a lot of interest in the 11,600 years ago as well, and the strongest suggestion of what caused that sudden rise in temperatures accompanied by meltwater pulse 1b was a second encounter with more fragments of the debris of the comet, this time the impacts not being on the North American ice cap, but in a major ocean, probably the Pacific. And that then puts a huge plume of water vapor into the upper atmosphere and shrouds the Earth and creates the greenhouse effect that accounts for the radical rise in temperature that occurred 11,600 years ago. More science needs to be done on that.
An additional difficulty for alt history purveyors is that when we are talking about a series of extinction events, rather than one big one, there's the problem of having to explain how a lost advanced civilization that was spread around the globe could not have survived. This series of extinction events would need to have happened in relatively quick succession, otherwise there would have been time for the civilization to bounce back. But even though the impact hypothesis doesn't fit their story all that well, they still are enamored with it. And one reason is because it is a rare thing when they can use actual published science papers to back up their claims. Most of their evidence can be found only on the internet and in pop books, so when there are actual scientific studies, this is something to put up on a pedestal. But we cannot forget that the impact hypothesis has no direct bearing on whether a lost advanced civilization existed. This is even admitted by some.
They are not saying that it also wiped out a lost advanced civilization of prehistory. I'm saying that.
Yeah.
The only way to know if there was an advanced civilization back then is to find it. But I think we should still look into the matter of impacts. If there was a series of mass extinction events, then this could explain why evidence of the lost advanced civilization is lacking. Maybe. I just got these new earbuds. They're called the Raycon Everyday Earbuds, and I have to tell you, they're fantastic. I've always hated putting earbuds in my ears because they're usually uncomfortable. After 5 minutes, I want to just toss them. But these ones don't bother me at all. And one of the reasons is because they're designed so ergonomically well, and they have several different size gels. So I just picked the one that fits my ears the best, and now I can listen with no pain. I can also choose between awareness mode or active noise cancellation, and there are touch controls right on them, so I can just tap to adjust the volume or navigate tracks or whatever. I like to use them when I'm writing. I'll put on some music and get me in the right mood. Or when I'm walking the dog in the morning, I'll listen to a podcast. Anyway, I thought you might want to know about these in case you wanted to get a pair. They're high quality, water resistant, dust proof, and at the same time, very affordable. You can hook up 2 devices on it, and it will automatically switch to whatever device you're playing. There are 2 mics on each earbud that work very well, and so you can also use them to make calls. The battery, when fully charged, has 32 hours of life, and the part about charging that I really like is it charges fast. With 10 minutes of charging, I can get like an hour and a half of battery life. So I contacted Raycon and I said, if I tell my viewers about the earbuds, can I give them a discount? And they said yes. So if you click the link I left below the video, you'll get an exclusive World of Antiquity discount on the Everyday Earbuds, or any of the other Raycon products. There's also a 30-day satisfaction guarantee, so if for any reason you don't love it, you can return it for a full refund or an exchange. But I think you'll love it. One of the criticisms of modern geology that you will hear alternative history proponents give is that today's geologists do not give enough consideration to the idea that catastrophes have shaped Earth's geological history.
Many scientists have got a vested interest in what is called uniformitarianism or gradualism, and they don't like to hear about cataclysms having any major impact on the story of life on Earth. There's a denial of the role of cataclysms in the human story. Yes. And there is even a word for that in science, and it's called uniformitarianism. And this is a particular philosophy of science where the view is that everything as we see it in the world today is how things have always been. So if we don't see cataclysms today and they're not playing a major part in our story today, then there weren't cataclysms and they didn't play a major part in our story in the past.
Adam Sedgwick, Roderick Murchison, we could go through the list of those. They all were almost to a man catastrophists. They believed that the features and things that they were seeing in the landscape could only be explained by means of catastrophic, outsized type events. What happened when you get sort of to the mid-19th century is you had Playfair, Lyell, and Hutton were the three who essentially codified the uniformitarian interpretation of Earth's history. And again, like I said, it was very potent, very powerful for understanding sedimentary processes, understanding erosional and depositional processes, all of these things. But it became codified as dogma by the time you get to the establishment of geology as an academic discipline in the late 19th century. They wanted to basically come up with this textbook framework that could be codified and taught as dogma.
I always thought that today's geologists accept the ideas of both uniformitarianism and catastrophism. So the first thing I wanted to do was to consult with a geologist to talk about the idea of catastrophes and mass extinction events in general. So I reached out to Rachel Phillips, a geologist and professor at the University of South Carolina. She has a great YouTube channel called GeoGirl that you should check out. Rachel Phillips, thank you so much for joining us today. I just have some questions I want to ask you, and I'm hoping that you can clear a few things up for us, because this area is not really my forte. So I wanted to know from someone who actually knows geology, knows about mass extinctions, and what they could tell us about this. So thanks again for joining us.
Yeah, absolutely.
In my travels, I hear people talking about this sort of rivalry between two different ways of approaching geology, uniformitarianism and catastrophism. And well, first of all, can you tell us a little bit about the difference between the two and how they play into geology? And then I want to ask you the question if there's any truth in the claim that some people make that catastrophes aren't really considered by modern geologists today. They don't really think about catastrophes and what their effect on the geological record are.
Yeah, of course. So for the first thing, the uniformitarianism versus the catastrophism, basically uniformitarianism is kind of like the fundamental thing that geologists think about, which is, you know, the geological processes that occur on Earth today, like sedimentation, deposition, just rock formation, the rock cycle, basically, those have occurred throughout Earth's history. That's the idea. And that basically helps us understand, the way people summarize it is the present is the key to the past. So with the knowledge that, you know, these processes have been occurring throughout Earth's history about the same rate and, you know, the same way, we can reconstruct kind of how Earth has been shaped over time geologically. And that's kind of how we can use uniformitarianism, and it works really well. But then, you know, catastrophes, the catastrophism part of it is kind of, instead of gradual, slow, you know, geologic timescale processes taking place and slowly forming Earth, you know, it's this idea that, you know, rapid, abrupt catastrophes kind of have punctuated Earth's history, and those have largely caused, you know, how Earth has ended up. I think early on, more so than now, these two ideas were more so rivals. And now I think the geologists that I surround myself with in modern geology, we tend to think that both of these things played a big role and continue to play a big role in shaping Earth over geologic time, of course. And, I think that if anywhere, the idea that catastrophes don't, can be dismissed or don't play a role and it's just uniformitarianism, if anywhere, that idea, I guess in my the way that I think about it, that might have come from kind of just a fuzzy line between the two definitions, because, when we first thought about these ideas, they seemed, radically contrasting each other. But when you think about it, for example, mass extinctions, I talk a lot about mass extinctions on my channel, and I think of them as catastrophic events. But, if you think about it, they've happened so regularly throughout Earth's history that one could argue that they're this regular patterned process that occurs on Earth that could fall under the category of uniformitarianism, because they're this uniform, kind of almost predictable type thing that will happen and has continually happened.
So catastrophes happen sort of at intervals throughout Earth's history. So
yes.
they're not unusual. Is that what you're saying?
No, not at all. And yeah, they might be, abrupt and punctuated and not predictable per se, but they happen. I mean, they've happened throughout Earth's history over and over again. There's a few very famous mass extinction events in Earth's history that get a lot of attention, but there's been hundreds, I mean, probably thousands that have occurred. So it's not,
Really?
There is
thousands of catastrophes.
Yeah. I mean, there's like background extinction, which is one thing, and then there's big spikes, and those are the mass extinctions. And of course there's local mass extinctions, there's global, it depends what you're talking about, but there's been, I mean, it's 4.5 billion years, they're millions of years apart, but they happen all the time on geologic timescales.
The way you hear some people talk, they're like, oh, those geologists, all they seem to think about is everything's uniformitarian, it's all gradual, there's never any catastrophes. But you're saying that's not true.
I'm not in the circles that I,
okay.
I haven't heard that.
Yeah. It may just be that there's a particular catastrophe that they want to promote, and because that one isn't accepted, then they have to have a reason. Oh, well, it's because they are all gradualists over there.
Yeah. I do think that sometimes people get so wound up in their hypothesis, they kind of get blinded to other data, but
all right. Well, and I want to talk about then some of these mass extinctions and catastrophes in history. Can you tell us a little bit about the ones that have happened in the past, the big ones especially?
Yeah, of the ones that we have recorded and well defined in the fossil record in the last 500 million years, there's 5 big ones that people talk the most about, that were seemingly, according to our current data, the biggest 5, and these include the End Ordovician mass extinction, which occurred around 445 million years ago. And this was caused, spoiler alert, all of them have been caused by climate change. The triggers for that climate change have differed for each event, but all of them, ultimately, the extinctions were caused by climate change. The Ordovician one specifically was caused by a cooling trend that initiated because of biological evolution, actually, which basically the evolution of land plants for the first time in Earth's history caused an increased cooling because they were taking up carbon dioxide, which is the greenhouse gas, and they led to more carbon burial, which I won't get into, but it caused cooling, and this major and sharp, rapid climate change caused extinctions, and likewise, the rest also were caused by climate change. The late Devonian is the next one, and that happened around 365 million years ago. That one was also caused by a sharp cooling trend, again caused by evolutionary advancement of plants. The Ordovician was non-vascular plants like mosses and stuff, and then the Devonian was caused by huge big trees and forests evolving for the first time, and so that again causes
just
big
the appearance of new types of life are affecting the climate.
Oh yeah, big time. I mean, that's kind of early Earth history. That's kind of just the way that things were happening, because biology was making these huge advances, and when those are so beneficial that they spread globally like plants did, then that causes major change. I mean, can you imagine going from no trees to trees covering the world? So it did. It caused really, extreme climate shifts, and that is never good for life, because life doesn't like fast change. The next three and the big five are all not caused by cooling. They were caused by global warming shifts. I mean, either way you go, anything that's rapid is harmful to life. But the next one was actually the biggest one in the last 500 million years, which was the Permian mass extinction around 250 million years ago. That one was caused by major volcanism. That one and the in Triassic. So the third and fourth one were both caused by major volcanism that led to a sharp increase.
So Mr. Spock and a bunch of people were coming from, no, this is a terrible dad joke. Okay. Volcanism. Oh, you mean volcanoes. Okay.
Yeah. Yes. Volcanoes. But yeah, so both the end Permian and the end Triassic, so 250 and then again at 200-ish million years ago, those two mass extinctions were both caused by global warming, which was triggered by major volcanism. And, a lot of people think like, oh, big, massive volcanic eruption could cause, mass extinction. Yes, but when we're talking about volcanism that caused these events, we're talking about like not just one volcano, like a big field of volcanic activity that erupted for like 2 million years. So huge amounts of volcanism leading to huge amounts of greenhouse gases emitted to the atmosphere and very sharp warming. And that, is what caused those extinctions. The last of the five is the KPG mass extinction around 65 million years ago, which took out the non-avian dinosaurs. And that one at the end of the Cretaceous was also caused by sharp global warming, but instead of being triggered by volcanism alone, it was triggered by an impact. So like volcanism, an impact of, big asteroid impact could cause similar climate changes. So if you think about a volcano or many volcanoes going off, they might initially cause kind of a ash blocking sunlight winter type scenario, whereas in the long term the greenhouse gases will take effect and it'll cause longer term warming. The same thing is true for impact. It throws up all this ash and dust, and initially there's a very intense heating period of the terrestrial environment where heating upon the immediate impact and the re-entry of material through the atmosphere causes just, intense burning and at the surface. And then longer term, several months to years after the KPG impact, we had the impact winter, so blocking of sunlight because of the dust that was still in the atmosphere. And then longer term after that, we had the warming caused by all the carbonaceous material that it impacted, which was released to the atmosphere as carbon dioxide, sulfur dioxide, all these greenhouse gases that led to a longer term warming trend, which caused the majority of extinctions at the time. So common trend is climate change.
But triggered by other things. I see.
Yes, triggered by volcanism or impacts mostly.
Okay. Now, the most recent you said was 65 million years ago, right? There are some people who are arguing for a more recent mass extinction. And it's usually in the context of arguing that there was a great advanced civilization that got wiped out by a comet impact. And this would be during the Stone Age. So I wanted to ask you, is it theoretically possible that a comet impact could cause a mass extinction? From what you've been saying, it sounds like yes, but I just wanted to get your thoughts on that.
Yes, absolutely. I think the Cretaceous KPG boundary is a great example. I will say that again, I think a lot of people initially might have misunderstood that extinction or even other events that were quote unquote impact caused to be due to the impact directly. But again, it's not the impact per se, but the climate changes that it causes. But in terms of indirect causes, yes, an impact could 100% theoretically cause a mass extinction.
Okay. So let's say we wanted to determine whether there was a comet impact on Earth in the past. How would we go about ascertaining that?
Yeah, of course. So, aside from the obvious, which is an impact crater, a lot of times you can have an impact, and an impact crater can, even though it's huge, be eroded. So that's not unheard of. But there are other things that are less easily erased that we can look for. And these things include, in the rock, we go and we, take big sections of rock, and we look for things like shock metamorphosed rock, or shocked quartz, often it's called. Basically, this is so metamorphism in geology is the process where rocks are altered by high temperature and pressure. And this can happen upon impact because the impact is, in the rocks that it's impacting, causing really intense heat and really intense pressure at that moment. And that kind of immediately melts and partially melts and alters a bunch of the rocks, both in structure and composition. And the way that impacts occur kind of alters or metamorphoses those rocks in a way that's distinct from other metamorphic, alterations. So we can sometimes see these things, and we call that structure that it forms shock structure, or shocked rocks. And sometimes when we see these in the rock record, we can say that that was caused by an impact. Another thing is, similar to that.
Would this be just where the impact would have occurred, or would it be more widespread?
No, this would be local, in proximity to the impact. It would be kind of, you should be able to see a gradual shift toward less metamorphosed rocks going away from the proposed impact site. There's, of course, after things solidify, there's, of course, like tectonics and erosion and weathering that can cause them to move out of the place they were originally, but, they shouldn't move across the globe. So you should have it relatively in proximity to where you think the impact occurred.
I probably should have asked this before, but could a mass extinction occur if the comet, or whatever heavenly body there was, but if it broke up in the atmosphere and impacted in more minor ways all over the planet?
Yeah, I think, again, every answer in science is it depends, but it does, because it depends on the size of the object, and how many fragments, how large the fragments are, when they broke up in the atmosphere, and I think mostly where they impact, whether it's in water, whether it's on land, whether it's at the equator or toward the poles, because that greatly affects then how they affect climate. Oh, and especially so one example with the Cretaceous impact was that it impacted rocks that were really rich in a type of rock called evaporite rocks, which are basically rocks that have a lot of carbonates and sulfate minerals. And those carbonates and sulfates, upon impact, immediately vaporized into carbon dioxide and sulfur dioxide. So those gases are then greenhouse gases. And so if it had impacted an area where there was less carbon and sulfur, then maybe it wouldn't have caused such, extreme global warming. So it really depends on the composition of the rocks too, that it's impacting. So, yes, but it depends.
I see. Okay. Would an impact in certain areas cause enough warming where it could melt the ice caps and cause major floods?
Yeah, that would be, it could. All my knowledge comes from things that have happened. But
specifically, I mean, there are some people who say that all the world's flood myths about catastrophes with floods are relating back to this event. This is one of the theories out there. It's relating back to this event when the comet impacted the Earth, or fragments of a comet, and this melted the ice caps and caused a worldwide flood. I want to know geologically how likely that would be.
Worldwide, the thing is with comets, even if they fragment, it's still a localized event. Unless literally it's all happening at once around Earth, which at that point, you wouldn't get a flood, you would get like massive like magmatism, and I mean you'd be back in the Hadean, like when Earth was molten. If it's localized, which it has been since.
But I mean, what about the overall climate change? Could the warming of the globe cause major floods? It would cause a rise in sea level, right?
It would cause a rise in sea level.
But this would be gradual or quick?
No, gradual.
Oh, it'd be gradual.
The thing is with the impacts is all of the immediate effects are relatively local. So like the metamorphism or the intense heating, everything there is relatively local because that's all associated with the impact and its ejecta that is all proximal to where it landed. And then the impact winter would also kind of hinder the process of any melting because that would lead to cooling. And then over the long term, which is much more gradual, you would get warming, but that wouldn't be a quick thing, you know? So, you know, it'd be on geologic timescales. If we're talking about, so the Cretaceous, for example, which is the one, you know, that I know, that one was over millions of years. So no, not with thousands or hundreds.
Okay. So again, I don't know if we finished this, but as far as what clues we would look for in the geological record to show that there had been, well, first of all, there had been a comet impact, but also that there had been climate change that could cause a mass extinction. What clues would we find?
Yeah, so again, with the impact, so things like shocked, you know, rocks and other impact, you know, hinting rocks would be things like ejecta, which are kind of these glass balls or teardrop shaped rocks that form by the immediately melting upon impact and then being thrown through the atmosphere and cooling while they're traveling through the atmosphere. So things like that. And also a big one that we talk about at the Cretaceous boundary is iridium. So iridium is something that's really, it's a common, or it's not common. It's very rare metal on Earth, but it's very much more common in extraterrestrial material, comets, asteroids, etc. And it, you know, there's a big layer of it around where the Cretaceous Paleogene boundary is, because after impact, that was all laid down after everything, the dust settled, per se. And then another kind of, then you have, instead of immediate impact evidence, you have like contextual evidence, which is like, you know, were there fires or tsunamis, which you'd expect proximal to the impact. If it landed in or near water, it probably caused tsunamis. The intense heating around it would have caused fires. So you expect to see those things preserved in the rock record if you have a good rock section from that area. And so those would kind of give you an idea of the impact. The climate, I mean, you know, this comes to like, are you looking for climate? Are you just looking to reconstruct paleoclimate in the rocks, or are you looking for impact-specific climate change? If you're looking for impact-specific climate change, you would probably look for some sort of order of events, like hints of warming and the immediate, you know, time after, very short-lived, intense warming.
By
like
the way, geologically, how do you determine whether warming is fast or slow?
Well, that would just be the measure of the section. Kind of, so, you know, the thicker the rock deposit, the longer, you know, something was the case, you know, whether those rocks indicate a cooling trend or a warming trend, you know, they, you know, the thicker it is, the longer it happened. But yeah, the immediate intense warming right after impact would almost be just hardly anything, just no thickness, but you get like a tiny little layer maybe in some areas proximal to impact where you might see evidence for iridium or fires or tsunami deposits, which are a little bit thicker, but you have to also have the context of this is a tsunami, so a lot more is deposited than in terrestrial environments where dust is just settling. So sometimes thickness isn't exactly, you know, related to timing, but you have to also have the context of what you're looking at as in the geological record. But then, you know, thereafter you'd expect to see evidence of impact winter and cooling, and then longer term warming. And there's, I mean, I don't know, it's hard to list one thing we look for when we talk about cooling or warming evidence, because there's so like hundreds of proxies that we look for. Most of it not visible to the naked eye. We look at the chemistry, the composition of the rock, and that tells us a lot about, whether it was cooling or warming. So that's kind of harder to go into detail because there's nothing physical really you'd see.
But the more evidences that you have, the stronger the case that it occurred.
Oh yeah, there's no case made when there's only like one of these things found. They kind of all have to overlap for then there to be like a really good case for an impact caused climate event.
Okay. Since we had this conversation, Rachel has done a full-length video on the Younger Dryas impact hypothesis called What Caused the Younger Dryas Cooling, Megafaunal Extinctions, and Clovis Disappearance, which covers points I do not cover in this video. So be sure to give it a watch over at the GeoGirl channel. Anyway, it sounds to me like today's geologists do incorporate catastrophes in the geological history of Earth. But hypotheses about catastrophes need to be judged on a case-by-case basis according to the geological evidence. Now I want to get into the Younger Dryas impact hypothesis specifically. This theory is the special interest of an organization called the Comet Research Group, who have been organized specifically to promote the hypothesis and to research comet impacts in general. On their website, they offer this description of themselves. Think our last space attack was 65 million years ago from the dinosaur killer asteroid? Think again. Killer comets are more common than you've been taught. At CRG, our mission is to find evidence about comet impacts and raise awareness about them before your city is next. They have a convenient overview page where they describe the YDIH in detail and speak in very positive terms that it actually happened. Why should we care, they ask? Because they can change climate suddenly, because they often cause great tsunamis, because more will hit us in the future. They provide funding for research on the YDIH, listing 63 scientists whose work they have supported, but noting that some scientists listed below support the Younger Dryas impact hypothesis, and some do not. They don't say how many. There have been a plethora of papers published on various aspects of the YDIH, so for someone just wading in, it can be confusing, especially if you're not familiar with all the jargon. But there are some papers that we can go to get the basics laid out for us. Perhaps no one has been a bigger defender of it than Martin Sweatman, a professor of chemical engineering at Edinburgh University. Do you remember him? He is the fellow who came up with the theory about Pillar 43 at Göbekli Tepe being a timestamp that records the Younger Dryas comet impact on it. I've already done 2 videos examining that idea, which you can check out later if you're interested. He wrote a defense of the impact hypothesis called The Younger Dryas Impact Hypothesis Review of the Evidence, which was published in Earth Science Reviews in 2021, and is a handy reference guide to the state of research, at least up to that year. Mind you, Sweatman is not a specialist in comets, or planetary impacts, or geomorphology or geology, and he has a vested interest in this topic, because his proposal that Pillar 43 at Göbekli Tepe records the impact event depends on there being an impact event. But his paper conveniently lays out all their arguments for you. People who are specialists in the science involved have written a lengthy reference guide as well. A team of 13 wrote a paper in 2023 called A Comprehensive Refutation of the Younger Dryas Impact Hypothesis, also published in Earth Science Reviews. We'll be talking to 2 of the authors in this video. If you are wading into this topic, these 2 papers are probably the first 2 you should read. The pieces of evidence usually given for the impact include these impact markers consisting of microscopic debris: magnetic iron-rich spherules, glassy silica-rich spherules, high-temperature melt glass, nanodiamonds, soot, aciniform carbon, fullerenes containing helium-3. You might wonder about craters. As far as I've been able to tell, proponents of the YDIH have not been able to positively identify any craters, saying that air bursts would not have made craters. And if there were any ground impacts, this would have been on the ice sheets and would have melted away. As far as this list goes, my understanding is that not all of these are generally accepted by scientists as evidence of impacts. But I had to talk to someone about that to get details and find out for sure. So I reached out to Mark Boslow, research professor of Earth and Planetary Science at the University of New Mexico. He is a physicist and an expert in planetary impacts and catastrophes. He is one of the authors of the Comprehensive Refutation paper. Here's what he had to say. Okay, everyone, I have here with me Mark Boslow. uh, from UNM, and he is going to tell us all about planetary impacts and catastrophes. So, Mark, thanks for taking the time to be with me today to answer some of my questions.
Sure, happy to be here.
Can you tell me a little bit about your area of expertise? What drew you into this discussion about the possible comet impact during the Younger Dryas period?
Yeah, well, good question. I've been interested in impacts actually since I was a kid. We used to camp out in the backyard and watch meteors during the Perseid meteor shower every August. I almost experienced a major fireball on a family vacation in
Really?
1972. Probably seen the home movie of it flying over the Tetons. We were there at the time, and we didn't know what it was. Of course, that was pre-internet, pre-YouTube, pre-everything, and I didn't even read about it for several years until I was in college. And there was an article about it, and it was actually observed by space-based sensors, which turned out to be something that I worked on many years later at Sandia National Laboratories. And actually knew the guy that designed the sensors that were aboard, these satellites that were there to observe possible nuclear explosions, and rocket launches and other things that generate light. And then I got very interested in impact cratering. I went to Caltech, started working in a geophysics lab with a two-stage light gas gun that fires projectiles at very high speed, and did experiments, high pressure experiments, both impact cratering and shocking minerals to very high pressures, to determine how they behave at very deep depths in the Earth's mantle. And I got to do some experiments at the NASA Ames Research Center, two-stage light gas gun, the Ames vertical gun, making craters. And then I got a job at Sandia and spent my time as an experimentalist doing more impact and explosion experiments before I switched in the mid 90s to doing computational impact physics. So my interest switched to the computing side, but I was remained interested in the experimental part, because that's how we validate, check to make sure our computational simulations are right. So I was very grounded in actual experimental data.
Wow. Well, it doesn't sound like you have anything against impacts in general. So,
Not at all. No, I
okay.
took, one of my favorite professors when I was at Caltech was Gene Shoemaker, who, he basically was the guy who, led what was at the time, or prior to when I was there, but during his time, pretty much of a paradigm shift in, the importance of impacts and impact cratering on the moon, other planets, and even the Earth.
Okay. All right. Well, about this Younger Dryas comet impact hypothesis, is it your position that it definitely did not happen, or that it could have happened, but they just haven't presented sufficient evidence for it?
Well, their hypothesis, and it's not just one hypothesis, they've got multiple versions of the hypothesis that actually contradict one another, but none of the ideas that they've published could have possibly happened because they're physically impossible. What they describe is physically impossible. Explosions in outer space, comet explosions, 500 kilometers above the surface of the Earth that created these firestorms in North America. Impacts and airbursts just don't work that way. It's just not a physically viable hypothesis.
Well, are you saying like breaking up in the air, that doesn't happen, or it doesn't happen the way that they're saying it happened?
It doesn't happen the way they say. And their original Firestone 2007 paper described a 5 kilometer diameter comet breaking up in outer space and exploding in outer space. And that doesn't work. Now, other versions, yeah, they describe things exploding in the atmosphere, but that's something different and a different physical process that is viable. But now they're claiming that there were thousands of these things, and I don't really see any evidence for that. I mean, something like that, less than 13,000 years ago, the evidence would be obvious and undeniable, and it wouldn't have taken until 2007 for people to figure that out. Gene Shoemaker would have figured it out, and probably somebody before him.
Well, as I understand it, you've done some research on the Comet Research Group. Um,
Yes.
and I want to hear a little bit what you found. Can you tell me a little bit about, how it came together and what your assessment
Yeah.
of this group is?
Yeah, so I mean, they didn't create this Comet research group until I think it was 2016. They started publishing, this group started publishing, and their first, publication in the scientific literature was this 2007 paper, but they had already published some stuff going back to 2001. There was a paper by, the lead author was Firestone and Topping, and it was in a newsletter called The Mammoth Trumpet. And they first started putting their ideas out there at that time, and then they published a book in 2006. But the scientific community wasn't paying
Wait, they published a
attention at all
book
to that.
before they published a scientific paper?
Yes, yeah.
Okay.
And it was Firestone, West, and some other guy whose name I can't remember, who was like their publicist, and I think who worked for the publishing company that they published in, which was known for publishing sort of pseudoscientific stuff. Um, uh, uh, New Tradition, Inner Traditions Bear and Company. And if you go to their website, you can see all sorts of kind of alternative stuff, not scientific. So that was their entry into this. Um, and most of the content of the Firestone 2007 paper, which was in the Proceedings of the National Academy of Science, that research was done in support of this book for Inner Traditions. And so it never really had a scientific basis.
Peer-reviewed papers have come out by them, right? Several of them have passed peer review. Surely that must count for something. They got actual scientists publishing peer-reviewed papers.
That's right. And we were unaware of this, or at least I was unaware of this. When the Firestone paper came out in 2007, we all assumed that it had been peer reviewed by the normal process. But somebody at some point started looking into this and realized that no, Proceedings of the National Academy of Sciences has more than one track for peer review. And if you are a member of the Academy, you can kind of bypass or end run the normal review process, get one of your pals to act as a prearranged editor and send out your paper to some pre-selected friendly reviewers. And so it appears that that's what happened with all their early papers. At least 7 papers went through a process that was either that or something very similar to that, with the same prearranged editor or communicating member in every case, somebody who had actually expressed the opinion that it was their job to get this stuff published, which is not normal peer review. Normally, an editor, it's not their job to get it published. It's their job to make sure that it's right, that it doesn't violate any principles, and that it's properly peer reviewed. So I don't think any of these early papers were properly peer reviewed.
I see. More recent ones perhaps have been, or no?
Well, yeah, there were papers published in the journal Geology and Scientific Reports, and several other journals, Journal of Glaciology. But here's the problem I see. I think by the time it got into being submitted to those journals, the reviewers and the editors saw these PNAS papers, and they hadn't been clued into the fact that those weren't properly peer reviewed. So they assumed that like a lot of the evidence that was presented in those papers, or the claimed evidence, really didn't have any true evidence to back them up. So in some sense, I think that, the evidence was laundered into peer review. It was never properly peer reviewed. And then once it was perceived to have been peer reviewed, it became accepted and repeated, and through repetition,
It's something that
people
they could
started
build on.
thinking that it was legitimate evidence. And I mean, one example of this is one of their very first major claims, and that was the discovery of fullerenes with extraterrestrial helium. They have never published any evidence for that. They made a claim in the Firestone 2007 paper. It's been repeated and repeated again and again, but they've never coughed up the actual evidence. Nobody I know has ever seen it, and I'm guessing that most of the co-authors have never seen any evidence. They're taking it on faith.
What, in your opinion, are the biggest weaknesses of the evidence for the Younger Dryas comet impact?
Well, the biggest weakness is they haven't let us see it. I mean, it's like that's not normal in science. When people ask, can I see your what is your evidence for fullerenes with extraterrestrial helium? And it's like they either ghost you, they won't reply, or they get angry that you would dare ask them, like you would challenge their honesty, but we haven't seen the evidence, and the evidence we have seen is more consistent with more mundane explanations. Like they found what they call scoria-like objects. Scoria and slag are basically indistinguishable. They use it, in candidacy, oral exams for candidacy to allow graduate students to become PhD candidates. That's one of the tricks. It's like bring in a piece of slag and ask them what it is, what kind of rock it is. It looks like a rock. And so scoria is the natural version. Slag is the human made version. And they have found this stuff like right next to historic railroad tracks. And they've been told this is railroad slag. This is not, you're calling it scoria-like, and you think it's formed by some mysterious airburst process. It's railroad slag. I mean, that is repeated over and over for a lot of what they are identifying as created by some kind of mysterious airburst process that even people who model and study airbursts and have published on airbursts don't really understand, because it's not consistent with the way we understand how airbursts work.
Oh, okay.
All
right. So
there's mundane things like carbon spirals. Those are, you burn coal, you burn wood, you get that kind of stuff coming out of smokestacks. And that's probably the simpler explanation for carbon spirals with anomalously young ages, is that the ages aren't anomalous. They really are only a couple hundred years ago, and they came out of locomotives that were burning wood in the firebox. So there's simpler explanations for everything they're finding.
I see. So in a nutshell, you're saying that where you need evidence to show that it wasn't actually an impact, that's where they don't have it. But the other evidence they have that they say is for an impact could be evidence for something else.
Yeah. And then, they always interpret everything. This isn't the normal way people do science. Most of us who do science are always asking, what could we be getting wrong? Is there a simpler explanation? Are we misinterpreting this? But for example, when the Hiawatha crater was discovered under the ice in Greenland, all their money was on, this is going to be 12.9 thousand years ago. This is our impact crater. And all of us, the skeptics, were saying, the probability that there was an impact, it's inconsistent with anything that young. And the probability that there would be that big of a crater that was that young are infinitesimal. It's got to be older. And it turned out to be older, way older, I think 58 million years old or something like that. Nothing to do with the Younger Dryas. And some of them have moved on. It's like, well, that just proves that it really was an airburst. It didn't hit the ground. And others are saying, oh, they got the dates wrong. So, there's a lot of special pleading that goes on too.
Yeah, you could, when I read their material, I get the impression that they just really, really, really want it to be true.
They really want it to be true. They want to be doing paradigm changing research, but ironically, they appeal to Shoemaker, they appeal to Alvarez as having done paradigm changing research, involving impacts. And it's true, they did. But now that's the paradigm that they're now overthrowing. It's like, well, Shoemaker was wrong. If they're right, Shoemaker was wrong. Alvarez was wrong. Impacts and airbursts are nothing like those guys were claiming thought. And in fact, Carolyn Shoemaker, who discovered Comet Shoemaker-Levy 9, is she passed away recently. She was one of their biggest critics and very vocal about it.
Do you think any part of their research has been valid or has increased our understanding of this period?
That's a good question. And there's one element, and a lot of my colleagues will disagree with me on this, and that is the possibility of a resonant swarm. So there's this idea, and in my opinion, they carry it by orders of magnitude to the extreme. But the idea that there was an object, a comet, that was in orbit around the sun, and it shed pieces broke off, and those pieces got trapped in a resonance. So there's a cluster of this stuff that's in an orbit that occasionally crosses Earth's path, and there can be an increase in the flux of impacts or airbursts. And I think that could be true, but at a much smaller scale. If it's true, then for a short period of time, in certain years and certain times a year, the increase in the probability of a Tunguska-like explosion, and that was the 1908 explosion in Siberia, there's an increase in the probability of events like that. And there may be fireballs, an increase, big meteor showers with exploding fireballs, but up high in the sky that don't do any damage. That may be true. Some of my colleagues even reject that. I don't think we have the evidence to say that that is wrong, but the idea that, every so often there's a shower of 5-kilometer size objects like they're claiming for the Younger Dryas, that can't be true because we would have seen them. We're doing, sky surveys and have been doing for decades, looking for potentially hazardous objects, comet fragments, asteroids, whatnot, that are in orbits that could intersect the Earth. We would have found those by now. So those do not exist, and if they don't exist now, they didn't exist 13,000 years ago, because where would they have gone? They didn't all collide with the Earth, if that's the idea. So that would be the grain of truth. But a lot of falsehoods and big stories have a grain of truth at the center. And if there is a grain of truth, it's that. And the airburst, the idea of airbursts. Airbursts are a real thing, and things do explode before they hit the ground. Tunguska is our prime example of that. There are there's some evidence in the geologic record, and as there should be, that other airbursts and bigger airbursts have happened in the past. And one example of that is the Libyan desert glass. There's this strange, I can grab some off my file cabinet behind me right now and show you, that I collected in Egypt. I went there for a shooting of a documentary in 2006, which is kind of when we figured out that it was from an airburst.
Oh, interesting.
So I published that idea, and that came out right about the same time as Firestone's paper.
Now, right after the comprehensive refutation paper came out, and I mean like right after, actually it might have even come out slightly before it was finally published, was a refutation of your refutation, or rebuttal, I guess you could say, by Martin Sweatman, James Powell, and Alan West. I think one of whom was maybe somebody that could really comment on this, but it was in their own. Yeah. Well, there was a shorter version in Earth Science Reviews, but then they had the full version in their own paper, Airburst and Cratering Impacts. I think they are also the editors of that paper, which they.
Yeah.
But anyway. Yeah, I do want to bring up some of the objections, just a few that
Okay,
were maybe pertinent to what
sure.
you study, and to see
Yeah,
what your thoughts are about them. So the first thing that they complained about was that the comprehensive refutation paper that you wrote ignored the fact that the hypothesis has been updated. And you were attacking old
yeah,
ideas, okay? And that the current idea is that there was a giant, greater than 100-kilometer diameter comet that entered an Earth crossing orbit in the inner solar system
yeah,
and began a cascade of disintegrations. Numerous cometary
yeah,
fragments from the debris stream entered Earth's
yeah,
atmosphere and detonated
yeah.
above or collided with land and ice sheets and so forth. Um, and that this caused megafaunal extinction events and human depopulation events.
Right.
And that's the current theory, and you didn't really talk that much about that one.
Well, I mean, we already have. I mean, we've talked about that. I mean, numerous times, and we did talk about maybe not the specifics, but I mean, this 100-kilometer diameter object that entered the solar system, inner solar system, in I guess an Earth crossing orbit and broke up into pieces, some of which hit the Earth, and that involves Comet Encke, which is a real comet, but it's I think 5 kilometers in diameter or something. But they're talking about a swarm of airburst type objects. But think of 100-kilometer diameter comet that broke up. Okay, how many pieces would it have to break up to, where if the biggest ones were a kilometer in diameter? I mean, that's easy math. It's like a million 1-kilometer diameter objects. Where are they? Did they all hit in the Younger Dryas? If so, where are all the craters? Those are crater forming events. If they didn't all hit, we should see them. They'd still be in orbit. But we've only found about 1,000 1-kilometer and greater diameter objects that cross Earth's orbit. And we're running out. If they were out there, we would have found them. We would have found a
You
lot
mean
more.
1,000
There's not
just
even.
in general for any period? Is that what you mean? Or
Yeah,
from this?
yeah, and they're not
Okay.
correlated. Yeah, they're not correlated with any particular orbit. They're pretty much just random.
I see.
Um, so yeah, that can't be true because they couldn't have just disappeared. They couldn't have all run into the Earth, or the Earth would have a lot of really fresh, steaming craters right now, and some of them wouldn't have hit yet because this is a random process, and space is really big, and
Well,
they're not like
if they broke
laser
up,
focused on the Earth.
if they broke up in the atmosphere and burned up, then they wouldn't leave a crater, right?
Yeah, but they don't do that. I mean, a 1-kilometer diameter object is not going to burn up, get used up before it hits the ground.
I
I
see.
mean, that just doesn't work that way. I mean, that doesn't conserve momentum.
Hmm.
There's no way that can happen.
The next thing I wanted to mention, and maybe it's a side point, but um, uh, they took issue with the fact that your paper called coherent catastrophism a speculative hypothesis, a preposterous fringe idea, but you cite no evidence to support this view and fail to acknowledge that the giant comet origin model for the Taurid meteor stream is the working model for cometary scientists. And that's consistent with
Well, it's
coherent
not.
catastrophism. Okay.
I know a lot of cometary scientists, and no, that's not the accepted working model. There are a few people who think that, and they're all in the Comet Research Group and or associated with that idea.
What is coherent
But
catastrophism, just for the audience? Everything is on a timer? Is that the idea that it's not random, but it comes back at certain times?
kind of, yeah, yeah. So it's kind of all in this resonance. So there's like a 3.3-year resonance that's associated with Comet Encke, and it's in a resonance with Jupiter's orbit. So Jupiter keeps kind of pumping it and keeping it constrained in this orbit, and it comes around occasionally, and there's some orbital dynamics effects that changes its relationship to the Earth. So every once in a while, the Earth passes through this swarm and gets hammered, and that's what they are claiming happened at the beginning of the Younger Dryas. But those would be observable. There would be it wouldn't be based on finding like, railroad slag or, you know, pollutants coming from smokestacks. There would be stronger evidence
I see.
than that.
So you don't have
But
anything
so
against the general idea of it, but that they're taking it to the extreme?
Yeah, and they took it to the extreme from the very beginning. But the mathematician, a guy named David Asher, who actually did the orbital computations, he had something right. There really is a resonance, a mathematical resonance, and it's really possible that stuff could be trapped in it, but probably not to I mean, certainly not to the extent that they say, and probably not to the extent that it adds significantly to the risk, but it could be there, and there is some evidence that it is there. There have been occasions where there have been bombardments of very small objects that don't make it deep enough into the atmosphere to do damage at the surface, but there have been swarms of fireballs. In 1975, there was seismic activity on the moon that seemed to correlate with the time that this resonance came around, which would be objects hitting the moon and being picked up by the seismometers that were placed there by Apollo astronauts. So I hesitate to call that coherent catastrophism, though, because there weren't any catastrophes. There's no global catastrophe associated with that. And it's possible that even the Tunguska object was one of these. And yes, that would be a catastrophe if you were an Evenki person living in the area near Siberia herding reindeer at the time. If the family members were killed or if your reindeer herd was killed, that would be a catastrophe, but not in the sense that those guys are using the word catastrophe. They're talking about global catastrophes. So, and I think when Duncan Steele coined that term, he was talking about kind of global catastrophe level stuff. So I would call it a coherent swarm or a coherent addition to the risk or something like that. But I wouldn't even call it coherent catastrophism. And the Comet Research Group and their supporters, the Graham Hancock followers and so forth, they're always talking about catastrophism versus uniformitarianism. And that is, that is so old. It's like we're not stuck in uniformitarianism. Those of us, especially who study impacts, understand that there are very rare catastrophes. And that is what I would call what Duncan described stochastic catastrophism. Catastrophes do occur. They're rare. There's a kind of a power law distribution, but they do occur. That's true in volcanoes too, and tsunamis and earthquakes. Every once in a while there's a big catastrophe, floods. There's really big events that happen that sometimes dominate what you see in the geological record, but that doesn't negate the uniformitarian view. It's in a way, it's completely consistent with it.
Okay. Yeah. Now, another thing that they complain about is that they say, or you guys say, that the radiocarbon dates don't match up for these various things that they're trying to
Yeah.
line up at one particular time. And they say you
Yeah.
don't take into account the uncertainty principle of the radiocarbon dates. And it's possible that they match up if you take into account, that we have a range of possible dates for the radiocarbon, so that it's possible.
Sure. Yeah. You have a bunch of big sets of error bars and you can draw any line through it you want. And they drew the line that they wanted, but there's, who knows how many other lines that you could draw through at different dates. Or you could just say, the simplest explanation is when they find a layer of stuff, for one thing, they don't look throughout the entire stratigraphic column. They only look where they think it is, right? And if they looked up a meter or down a meter, they might find another layer of this stuff because cosmic stuff is always falling from the sky. So it's not always industrial, but in some cases it is industrial, like in sediments that are bioturbated, they've got roots, or They've been in fields that have been farmed or construction or they're rock quarry. You look at the list of their sites where they've actually collected their samples from. A lot of them have been disturbed. So there's a problem with the dating, and so they're finding the one layer that they think might be Younger Dryas boundary, but they don't know. And then they date it, and there's huge uncertainties on the age. And then it's like, oh, well, it must be because this is our hypothesis. So they're putting the hypothesis before their interpretation of the age of the layer that they find. And they basically admitted this. I mean, I've been told this by co-authors of these papers. They don't know. And so one analogy would be, somebody who does like me who doesn't have very good eyesight, and they're doing target shooting, and they're claiming, that they're hitting the bullseye every time because they can't see the target that well and it's blurry. And so it's like, well, it's like within the uncertainty of the blurriness of my vision, so it has to be in the bullseye because that's where I want it to be.
Yeah, yeah. The argument almost seems to be like they're saying, well, you haven't proved it's impossible, therefore, it still stands. You haven't refuted it like you said you refuted it.
Yeah.
Sure, it may be unlikely, but it's still possible. Maybe that seems to be kind of what
you have to be
yeah.
wrong about a lot of other things too.
Okay.
Like how our understanding about how much air heats up when you compress it, that would have to be wrong too. And there's a lot of evidence that we know how much air heats up when you compress it.
Mhm. Yeah. The other thing they have is they say in your paper that you claim that microspheral evidence alone cannot be used to establish an extraterrestrial impact event. But they say this contradicts a paper by French and Coburl in 2010, and they say that it
Yeah.
is possible. Can be used as evidence of a ET impact event. What do you have
Yeah.
to say about that?
Well, I mean, you said French and Coburl, but Coburl was a co-author of this paper, this refutation that
Oh,
they are.
so
I mean, so I trust that he knew what was in his own paper.
okay,
But
okay.
even if they, claim that, okay, these spherules also have other evidence associated with them, like these unambiguous signatures of high pressure impact, the mineral coside or shock zircons or whatever. Show us. Just let us see them, distribute. I mean, if this stuff is so abundant, then you should have enough to share with your skeptics or some neutral independent party who can look at these and say, oh yeah, these are definitely come from a shock event. But even then, it doesn't mean it came from a bombardment of thousands or however many comets their latest version says hit the Earth. Because we do know there are impacts on Earth and there are shocked minerals on Earth. So it does happen. It just doesn't mean that it did what they claim that it did.
I see. Yeah. Um, they say that your paper claims that a sudden impact winter can be ruled out through analysis of low resolution paleoclimate data. However, they say only high resolution subannual data can be used to investigate this issue. Um, Holliday et al.'s argument that the suggested impact winter must have lasted for several years is based on an understanding of volcanic eruptions, not extraterrestrial impacts.
Yeah, I think there's a lot of wrong stuff in there. One, it's like, why would aerosols or greenhouse gases caused by volcanoes act differently in the atmosphere than aerosols or greenhouse gases generated by impact? I don't understand that. I mean, there's an analogy there, and my colleagues in the planetary defense community who do risk assessment and publish about impact generated climate change do compare it to volcanoes. And second, I didn't realize that their impact winter lasted less than a year. That's not, that I don't know if they published that anywhere until now. I don't know.
I haven't
But
seen. Okay.
Yeah, I mean, we had a volcanic winter. I mean, the year without a summer, which was what year, 1812 or something, or somewhere thereabouts. I mean, that wiped out, a summer of agriculture, and a lot of people died. But as far as I know, there weren't any mass extinctions.
I wanted to ask, where do you think this is going? Like in the next 20 years, where do you think the YDIH will be?
I think it'll be pretty much where the Piltdown hoax is now. I mean, I think it's
Okay.
inevitable.
Okay. So it's
And I'm not the first to have said that.
okay. So you think it's
I think,
it's not only it's not going anywhere, you think it's gonna crash and burn.
yeah, I'm surprised it hasn't yet. And crash and burn in this context is an
Good,
excellent.
good, good words. Yeah. To sum up what I've learned so far, here are the issues we have with each of the evidences presented by impact proponents. Magnetic iron-rich spherules and glassy silica-rich spherules. The peer reviewers argue that microspherules alone are not diagnostic evidence for impact events because similar objects can form through various natural and anthropogenic processes. They emphasize that the identification of these spherules as impact products requires additional evidence, such as high-pressure minerals, siderophile element anomalies, or isotopic ratios. Without this context, spherules cannot reliably indicate a younger Dryas impact. High-temperature melt glass. The peer reviewers acknowledge that high-temperature melt glass, like Le Chatelierite, can form during impact events. However, they caution that melt glass is not unique to impacts and can also result from volcanic activity or anthropogenic processes. They cite multiple studies demonstrating that such glassy materials can be misinterpreted without clear geochemical and geological contexts. Nanodiamonds. The peer reviewers are critical of nanodiamonds as evidence for an extraterrestrial impact. They argue that nanodiamonds are not unique to shock-induced processes and can form in other conditions, including biological, diagenetic, and anthropogenic environments. Studies claiming nanodiamonds as impact markers often fail to demonstrate their exclusive association with impacts. Soot, aciniform carbon. The peer reviewers reject soot as conclusive evidence for an impact, explaining that soot and carbon-rich materials are common in sediments and cannot be linked definitively to a cosmic impact. They argue that widespread biomass burning has many potential causes, such as natural wildfires triggered by lightning or human activity. There's no compelling evidence that the soot observed at the Younger Dryas boundary was globally synchronous or caused by an extraterrestrial event. While proponents of the Younger Dryas impact hypothesis claim black mats resulted from catastrophic fires, the peer reviewers describe black mats as common stratigraphic features that form under diverse environmental conditions, including wetlands or organic-rich sedimentation, and argue there is no definitive link between black mats and impact processes. Radiocarbon dating inconsistencies further weaken this claim. Fullerenes containing helium-3. The peer reviewers say that fullerenes with extraterrestrial helium-3 have not been sufficiently demonstrated as evidence for an impact. Fullerenes are highly controversial as impact markers, as they can form in non-impact environments, such as through industrial or natural chemical processes. The authors note that claims of extraterrestrial helium-3 within fullerenes often lack robust supporting evidence or independent replication. When I began this study, I was most interested in the evidence that impact proponents have provided for the extinction of the megafauna and the extinction of human populations. They focus on the disappearance of the Clovis culture in North America. What did the peer reviewers say about that? I rung up Vance Holliday, retired professor of geosciences from the University of Arizona. He is one of the authors of that second paper I mentioned, and he specializes in the anthropology and archaeology of North America in this period. Here's what he had to say. Thank you for joining me today, Vance. I really wanted to pick your brain a little bit, if that's okay.
Sure thing. Yeah, good to be here.
First, let me ask you this. What were your specific contributions to this paper? I know everyone kind of put in a little, of their own expertise in here.
Well, there's a lot of people put in a lot of time and a lot of expertise. And everybody had something to say pretty much. I mean, some of the geochemistry was a little bit beyond me, but the aspects, I guess the main things, what I know the most about in the context of this is archaeology, the issue of extinctions, climate, paleoclimate and climate change. I'm not a paleoclimatologist, and we had some of those folks involved as well, but because of my other interests, I know enough about paleoclimatology to weigh in. Radiocarbon dating, soils, stratigraphy, basic late Pleistocene stratigraphy. So it touches on a lot of things I have interest in and experience in, which I guess is the reason why I followed it since it's first sort of appeared in the news, science news anyway, in 2007.
Okay, all right. Just generally speaking, do you think an impact of this kind is possible and just simply not demonstrated, or would you go so far as to say that it is unlikely to have occurred?
I've seen no evidence for it. Let's put it
Okay.
that way. I don't think there's a case. One of my colleagues years ago at a conference made a comment that if there was an extraterrestrial impact, it had no terrestrial impact. In other words, maybe something hit the Earth, but if it did, there's precious little evidence that I've seen, just based on what I know about these topics. Maybe it happened, but I don't. If it did, I don't think it had the. It wasn't catastrophic, and that's the issue, because it's described over and over and over as a catastrophe, as catastrophic. Absolutely not.
Okay.
Based on what I know.
How would you characterize the level of scholarship and scientific robustness of the papers proposing this hypothesis?
Boy, they vary. Depends on who's writing and what the topic is. It's sort of stunning to me that some of the comments about archaeology, about the key issue is extinction of this artifact type called the Clovis point. And archaeologists are guilty of this, but we often conflate the term Clovis with people versus artifacts. When you get right down to it, we're talking about the appearance and disappearance of an artifact style. And the argument is, oh, this artifact style quit being made at 12,800 years. They must have been wiped out. They must have been extinct, completely ignoring that artifacts come and go, as well as
the people can remain. Yeah, right.
They all come and go, and you can never find the exact endpoint of when a particular artifact style evolved to another. I mean, and why do they vary? I always bring up, a bit facetiously, but tail fins appeared on cars in the late 50s, and then they disappeared. Styles evolve. That's what you and I deal with.
The fin culture, it went extinct.
Right. Yes. So, but anyway, that's even more complex, because some of the best dating for Clovis shows that Clovis persisted after. So the thing, boy, that's a really good question that you asked, but it's a really difficult one to answer, because what I don't understand is why the people, and most of them, from what I could tell, are good scholars, they don't deal with the questions that we keep raising. For example, there's recent dating on Clovis that shows Clovis persisted after the time of the supposed impact. They haven't confronted that. Relatedly, extinctions. Now, the late Pleistocene extinctions is a very complicated topic, and people have been debating it for decades, and we still don't know why it happened. But their argument would have you believe all these megafauna, mammoth, and all these others all went away, all disappeared exactly at 12,800 years, and that's just blatantly not true. There's paper after paper after paper that show the extinctions were staggered. Different species became extinct at different times in different places, continent to continent, it varies. So yeah, in North America, mammoth did in fact become extinct at about that time, but lots of other animals were extinct beforehand. And we've brought this up over and over and over in our papers, and it's ignored, or in fact, they just keep persisting with this notion that it happened. And I don't understand. And that's the frustration, is that
and normally you would not expect it from scholars of this caliber.
Yeah, I guess that's a good way to put it. Yeah, it's beyond me. I don't understand it.
Why do you think your paper, the comprehensive refutation paper, needed to be published?
Well, it started as a commentary on a paper that was published in 2021. A bunch of us were working on a commentary because the paper had a lot of problems. And we spent about a year.
Which paper was that?
Well, Sweatman published a paper in 2021. I didn't know who he was first time he came on the scene in this context. He's an engineer, as far as I know. And this paper was let's put it this way, it was not, from my perspective, it was not well informed. Mm-hmm. And quite a few of us decided, in a variety of fields, how many authors are there? 12 or something, and cover all sorts of fields from archaeology to impact physics. So we started writing a commentary, and we all had other things to do. And after about a year, we had this big paper, and we finally thought, well, this is crazy to spend our time writing a commentary. Let's refocus it as the other side of the argument. And that's the argument I made to the journalists is, look, you guys published this big comprehensive paper. It's got a lot of problems. We think we should have equal time. And so then it just evolved as the dozen or so of us.
Was it something that one person invited other people to join in on, or was it kind of it just kind of formed naturally?
Well, both. Initially, see, there are several of us have co-authored these sorts of papers before. I was part of a big one in 2014. I was part of a big commentary in 2016. And it keeps coming up. That was the thing, is the frustration. We all see that the same issues keep coming up over and over. And we thought, okay, look,
it gets a lot of press too, right?
And what was that?
It gets a lot of press as well.
Yeah, exactly. There's that too, the popular press. And so we just, a number of us, must have been 5 or 6 who are in touch fairly regularly on this, and let each other know when papers come out. And then we got some other people involved. So it was a little of both. It sort of evolved organically, because several of us have been commenting on this for a long time. Mm-hmm. And it seems to no avail, it seems.
So would you say that the general approach of the paper is to analyze the strength of the others' arguments rather than presenting evidence of your own that it didn't happen?
Probably more of the former. You can't prove a negative, right?
Right.
No, what we're doing is testing the hypothesis with the data that is already out there. And I guess that's the thing, is that most of the data that we cite in the papers is available. It's been out there. With extinctions, there's a huge literature on extinctions. And so we're pointing that out. There's a big literature on archaeology. That's one of the things very early on in the 2007 paper, the first well-known paper, but there were some other publications that preceded it. I was just stunned at some of the comments authors were making about archaeological sites that I've worked on, that I've been to, that I know intimately, and they're saying stuff that it isn't true. They're not paying attention to the published literature. And so that's what raised my skepticism initially, because I was seeing these comments about Clovis archaeology and the Clovis site. There's an archaeological site in Clovis, New Mexico, or near there, called the Clovis site. I've worked there, and so I know that story, and I know the extinction story pretty well. And it was very frustrating. So a lot of what we've written is raising all this information, bringing it up, synthesizing all this information that's, for the most part, already out there.
Mm-hmm. Okay. Yeah.
as a way of testing the hypothesis, which is, that's, as far as I'm concerned, that's what you do in science. If there was an impact, as I said, I don't see the evidence. It's very poorly, as far as I'm concerned, it remains very poorly presented.
Okay. What would you say are the biggest weaknesses of the hypothesis?
Okay. Well, in part, no, there was no extinction of Clovis people. The animal extinction is very complex and varied, as I was just saying. Another issue that, again, we've brought up, the dating. To make this case, you should have accurate, high precision dating. Mostly, for this time period, it's based on carbon-14. Right, there's some other dating methods have been used, but carbon-14 is the main one. And so they should have, the proponents should have accurate, precise dating of exactly the time period involved, but also throughout their stratigraphic sequences. And then the other part we haven't even gotten into are the indicators. There are a variety of chemical and geochemical and particulate indicators that are supposed indicators that are proposed as being the result of comet impacts. And in fact, there is no single indicator that's a smoking gun for an impact. That's a weakness. That issue has been debated endlessly. And finding those in the field and dating them. And when you dig into the different sites, literally and figuratively, go into the literature, the dating is not very good in most cases. It's rarely related directly to the zones where these indicators are coming out in these archaeological sites. So the whole argument is, there was this event at 12,850 years ago, or 12,800. So the whole issue is proving that these indicators occur at exactly that same time period. And the dating isn't that good. There are over 50 sites now that have been proposed that supposedly have these markers. And the dating is, at most of them, in some cases, it is literally non-existent. It's just asserted. And in other cases, it's a very poor stratigraphic provenience, just like archaeological provenience, which you're familiar with. Geologic provenience is the same thing. There are at most a half a dozen sites where they have decent dating for the zone where they're getting these supposed impact indicators. So for me, that's one of the worst. And they've never, the proponents, this has been going on for years. We keep raising this issue. One article, one of my colleagues published in 2014, they went through all the sites at the time, very extensive discussion of the dating at every site that was then proposed, showing how poor the age control is. And the impact proponents have never dealt with those criticisms. They've never countered and said, oh, you're wrong, or we have better dating. Frankly, they just ignore it.
I see.
And the Sweatman paper that came out in 2021 just accepted all the dating as proving, to go back to something we were talking about before, proving that all these indicators line up using statistics. We're accused of not understanding error in statistics. And the problem is, what we're talking about is error in radiocarbon statistics, which is, anyway, we don't have to get into that. But
I do want to get into it a little bit, because Martin Sweatman on his blog made some responses to the paper.
Oh yeah, yeah.
And I want to, if you don't mind, I'd like to bring up
a few things
that he said about it, and I'd love to hear what you have to say about it.
Sure.
He says that there are 8 sites consistent with the YD impact date with a 95% uncertainty. That's less than 200 years. 10 more sites with a 95% uncertainty of less than 400 years, and 9 sites under 1600 years. I don't know if that's right, but this is what he says.
I'd have to look.
Okay.
But again, that's low precision.
Mm-hmm.
That's part of the issue. Early on, several of the key players in this debate were the ones that said you've got to have high quality dates, very high precision, less than 100 years standard deviation, directly from the zone with the impact markers. This was impact proponents making this argument, and they're correct. That's what it takes: accurate, high precision dates. And a lot of the dates, going back to what I was saying earlier, a lot of the dates that he's citing either have problems in their stratigraphic context or other problems of accuracy. And quite a few of the sites that are dated, I counted them up once. Very few have standard, or have the radiocarbon dating has standard deviations of within 100 years, plus or minus 100. Quite a few of them, as you just read out, like 400 years standard deviation.
Yeah.
That means, and now it depends on whether it's 1 or 2 standard deviations, but that means a 800-year time span. Well, if you're trying to prove that event happened at 12,850 years, having a 400-year or more standard deviation isn't proof for most of us.
Yeah. He uses a probability argument. He says that since these are caused by Tunguska-like events, and those events are so improbable, that it is more likely that it would all be caused by the same event than that there would be many Tunguska-like events.
Well, he's assuming that all these indicators are produced by extraterrestrial events, and we don't know that.
Mm-hmm. Mm-hmm.
We don't know that. In fact, there's a site that I've worked on. It's probably the site I know best in Lubbock, Texas. And Sweatman even accepts the data from this site. There's a huge spike in nanodiamonds and a huge spike in microspherules at less than 11,000 years, well after the supposed impact, and no indicators at 12,800. And we're only 100 miles from Clovis, New Mexico. And so it's, are there multiple impacts that we're all missing and aren't showing up in the geologic record? I mean, again, the argument, they're proposing this, so the burden of proof is on them to demonstrate the uniqueness and to demonstrate that all of these indicators are in fact telling us that there were supposed indicators are telling us that there was an impact. And that hasn't been shown. Yeah, he's making a statistical argument, but 400 years, again, the burden of proof is on them to show that all these things are lining up.
Yeah,
and they don't. They just don't.
Any other closing thoughts about this, or what you'd like to tell the general audience about it?
It would be one thing if this argument was being made over back and forth about specific kinds of evidence, and the responses we invariably get are focused on little bits and pieces of the issue, and they have the impact hypothesis people have yet to deal with all the criticisms, all the problems, all the things that you and I just talked about, all the problematic dating, the issue of extinctions, the archaeological record. Well, another thing too is the uniqueness of the Younger Dryas as a climate shift. And I think in what I just read, I believe that's Sweatman said in this reply, and other people, that it was a return to near glacial conditions. No, it wasn't a return to near glacial conditions. It had not remotely, but it was probably the last gasp of the last ice age. And there were a lot of these very dramatic flip-flops, cooling at high latitudes and high altitudes, but not, the Younger Dryas was not even a global cooling event. And also another thing is on the landscape, there's just no evidence for any kind of catastrophe. You don't see it in glacial records. You don't see it in stream records. You should see, if there was this global catastrophe, I would expect some evidence of some dramatic changes, and it's just not there.
To sum up, the peer reviewers reject the claim that the megafaunal extinctions were abrupt, synchronous, or caused by a single catastrophic event like the proposed impact. They note that the extinction timelines for many species were staggered, with some disappearing before the onset of the Younger Dryas and others persisting well into or beyond the Younger Dryas. For example, mastodons in the Great Lakes region and some South American megafauna survived into the early Holocene. This variability contradicts the notion of a singular impact-induced extinction event, or series of extinction events in a narrow time period. The peer reviewers also argue that there is no evidence for widespread human population decline linked to the Younger Dryas impact hypothesis. Claims of a post-Clovis population decline are based on flawed analyses, such as misinterpreting gaps in the archaeological record or radiocarbon plateaus. They emphasize that most Paleo-Indian archaeological sites reflect natural sampling limitations rather than evidence of population collapse. So it would appear that the Younger Dryas impact hypothesis fails to provide robust evidence for a direct causal link between an impact event and the extinction of megafauna or disruptions in human populations. These extinctions and cultural shifts could very well have been caused by a combination of environmental changes, climate variability, and human activity. There is one more subject related to all this that I needed to examine in more detail, and that is matters related to the pieces of evidence given by people like Randall Carlson for catastrophic flooding in North America around the time of the proposed impact event. Here are some of the things he has said about it.
We did a fantastic research trip across the Channel Scablands of Washington State, which Randall has been walking the walk on for decades, and he just showed me the absolute irrefutable evidence of cataclysmic flooding in that area.
What we did was we traveled from Portland to the Twin Cities, and what we did was essentially followed the southern margin of the Great Ice Sheet for the most part. And what we were looking at was this evidence that the whole ice sheet had undergone this massive, catastrophic, sudden meltdown. And basically what we saw in the landscape was evidence that was oceanic level currents flowing off the ice sheet.
I reached out to an expert in North American Ice Age flooding to see if there's any truth to what Carlson has been saying. His name is Vic Baker, and he is Regents Professor of Hydrology and Atmospheric Sciences, Geosciences, and Planetary Sciences at the University of Arizona. If anyone is going to know something about this subject, it will be him. Can you tell everyone a little bit about what your area of research is and what you've been studying, particularly in relation to the Ice Age floods?
Okay. This is always a tricky question because my career is long, and it went in many different directions. I basically finally decided on what kind of geologist I wanted to be in graduate school back in the late 1960s. And the problem that I got to that led me into basically all my subsequent science was the problem of the origin of the Channel Scabland in Washington State, which had been proposed by a scientist who fortunately was still alive and began his intensive work on that problem just about 100 years ago. His name was J. Harlan Bretz. And I had this idea that that was the right kind of science for me to be involved in. So I got involved in that problem. Bretz had tried to argue against many critics in science for the merits of this idea that cataclysmic flooding had produced the landscape in eastern Washington. And as I subsequently learned from him and from studying how he did this, he was absolutely and totally invested in this investigative approach to science. I mean, for him, this was something he would defend, but only because the facts were overwhelming for this regard. And he had a long history of arguing his point, but it was not because his theory was so great. Actually, he had huge doubts about his theory as he went along. It was just that every time he looked at it, more and more new facts came about. And these new facts that were completely surprising to him were consistent with this idea that, in some sense, he was worried was crazy. And so he stuck to it. He had a kind of stubbornness, but he felt his stubbornness was being made, it was just being shown by nature itself. And so he persisted. And finally, when I got involved, he had achieved kind of respect for this idea. But there were those who thought, oh, well, this is so immense, these floods. There's no way that it could physically work. Well, I had been studying as a hydrologist and as a person interested in engineering, applied science, the techniques that you use to evaluate the mechanics of erosion and deposition. So that was my thesis. I applied those techniques. And they were completely consistent with what Bretz was saying. The other scientists had ignored doing that. So that kind of was an impetus to my career. I got a faculty position even before I had finished grad school. I was an assistant professor at University of Texas at Austin to work in this area of applied science and studying mechanics and things like that. But then something completely unexpected happened. A spacecraft, Mariner 9, returned images from the surface of the planet Mars. And the images showed immense channels that had been cut into the surface of Mars billions of years ago. Well, those channels had aspects that were like the channel scabland that I had just been studying. So I started working in planetary geology, particularly the planetary geology of Mars. And I also continued my studies of floods. Well, ultimately, my planetary work induced me to move to the University of Arizona in 1981, which has arguably the best planetary science department, the best hydrology department, one of the best geology departments. So it was a perfect place for me to go. I left Texas, I went to Arizona, and I continued working in these diverse areas, but with a focus on understanding what nature presents to us about the most extreme kinds of floods that have happened anywhere. Earth, Mars, if they were on other planets, I would be studying them. So in a sense, I didn't have a particular plan for my program. What I have done was basically nature presented it, and I just followed where that went. And so I became a scientist of studying the biggest floods that have happened, including ones that are damaging to human beings. And I studied the Tohoku Oki tsunami in Japan because that was just a fantastic example of a flood. It was a flood of seawater coming across the land that had incredible impact on human beings. So my whole career has been about studying these kinds of extreme phenomena, particularly associated with flooding.
Now, you might be familiar with Randall Carlson. One of his things is to look at the scablands. He even takes tours to the scablands. And he says this all shows proof of some kind of massive single event cataclysm, which wiped out the megafauna in North America basically reset culture there. It wiped out the Clovis culture, things like that. Now, wonder what the evidence actually points to in regard to that. Was there a single event that we're talking about here?
Well, one of the problems is the timing. Here we have to talk about multiple lines of sort of technical evidence about the ages of the flooding. We have multiple techniques that show that this flooding did not occur, at least the most massive kinds of flooding, in the time frame that is being claimed by Carlson. There were some larger flows than exist today during the younger Dryas time, but they were incredibly smaller than the really big flows, which occurred much earlier. And there is so much evidence for that relationship that it is completely unproductive to think about it in a way that relates to the younger Dryas. Completely unproductive scientifically. That's why scientists don't really pay much attention to that relationship, because there's, nature would have to be incredibly perverse and intentionally misleading us to have produced all the kinds of evidence that shows that that time frame is different. It isn't just evidence in terms of various radiometric techniques and things that have been criticized by creationists and others. This is actually things where something is placed on top of or eroded into something else.
So the order of events.
The order of things is completely inconsistent with that idea. Also, we know that there were big cataclysmic floods in many parts of the world associated with the late Pleistocene large ice sheets. Now, those ice sheets reached their maximum at about 18 to 22,000 years ago. A little bit different in different parts of the world. And associated with those near maximum times, we had many different ways that cataclysmic flooding was generated in different parts of the world. But they didn't all occur at the same time. They had different ways that they occurred. Some of them we understand fairly well, like ice dammed lakes, which is one of the, let's say, best understood mechanisms for the channeled scabland mega flooding. Not necessarily the only mechanism, but really one that has been well documented is the failure of an ice dammed lake. And that, as I said, many kinds of evidence show that that definitely occurred 16,000 years ago. But even the flooding at 16,000 wasn't the biggest. New work, only partly documented in papers, but which I am, part of teams working on it, suggests that the really big flooding was a little bit earlier than that, maybe 18,000, maybe 19,000 years ago. And anything that was occurring in younger Dryas time, and there were situations that led to larger flows than we have today, was incredibly smaller than that. And the same kind of story is shown in other parts of the world. In many ways, the scablands being an early area of study, Brett's taking it back 100 years, has received more attention. But there's many places that have had these cataclysmic flooding. Some of them would surprise people, like the English Channel was carved by catastrophic flooding. But it wasn't carved by catastrophic flooding 12,000 years ago. The English Channel was carved by catastrophic flooding much older than the last. It was carved in an earlier glaciation. And the evidence is pretty clear for that. Even in the scablands, there was phases of catastrophic flooding that occurred as much as 1 million years ago. And in fact, just 2 weeks ago, I was leading a 1-week field course for advanced graduate students from the University of Arizona, where we were out looking at all of the evidence. And one of our stops was had to do with some of this very ancient flooding that occurred in the Channel Scabland. And the evidence for that is that the flood deposits are rather different in some ways. They're clearly catastrophic flood deposits because they include big boulders. They're in settings that show the water had to be very deep to produce them, but they are deeply weathered. And that weathering, the alteration of the chemistry of the rocks from the surface, the development of soils and profiles on that, that all showed that the deposits are very old. Radiometric dating on the calcium carbonate deposits showed that these are at least hundreds of thousands of years old. Paleomagnetic studies of the polarity of the Earth's magnetic field was reversed, and that reversal occurred 790,000 years ago. So those flood deposits, which are in the Scabland area, they're much older. Now, we don't have as much data on those older deposits, but and all of this is work that is currently in progress. But to claim in absolute terms even the age of the flooding, and then to try to relate that to all of this other kinds of evidence that may be completely independent of that, is telling it a appealing story, but it isn't nature's story. So scientists don't take it seriously because of this. That's one of the issues here. What it is to be a careful scientist.
Yeah, how would you differentiate between a careful scientist and a not careful scientist?
Well, ultimately, a scientist is not someone who should be absolutely claiming authority and absolute claiming the truth of things. That is inconsistent with science. Science, exactly what their attitude should be is under discussion. I actually had discussions about this with the late Carl Sagan, because I also work in the planetary science area. And Carl was an advocate of what's called skepticism, that one should always be exceedingly skeptical of things. Now,
even your own ideas, right?
Yeah, well, including your own ideas. And that's the key part. My view is that an important element of science is called fallibilism. Fallibilism, which people don't maybe haven't really heard about, it's a philosophical idea, and as you may know, I'm into philosophy of science. It is the recognition that it's exceedingly difficult to know in absolute terms that you are completely correct, that you always have to be willing to admit there may be a possibility that you are wrong. And that's absolutely essential to science, because science is not about claiming that you have absolute truths. Science is about the process, the absolute dedication to searching, investigating, seeking the truth, and to do that with the sense of humility before the entity that has that truth. And the entity that has that truth is nature, reality, whatever you are studying. The reality of that is where the truth lies. Mm-hmm. And ultimately, whether you are somebody who is a theorist and trying to say the best things you can say about nature, things that sound good to others, you have to go to nature to see if that's correct. But the other kind of science, and it's the science that I ultimately came to invest my career in, is the one that starts with nature itself. It tries to interpret what nature is presenting to us. It's more like an investigator. An investigator doesn't go to a crime scene and say, I've got a theory about how this works, and I'm going to see if my theory is right. That gets investigators into a lot of trouble. Investigators go there looking for clues, looking for evidence,
But if you
looking
know
for,
who did it, you could just plant evidence, and then it'll make your.
of course, you have to be careful of that. But nature, and Einstein said this, nature is subtle but not malicious. Nature may make it difficult, but the truth is always there. Nature doesn't have a agenda to be evil, or it is magnificent, wonderful, beautiful. Human beings have a sense of that, and that sense, unfortunately, is manipulated by those who don't have the kind of attitude that I've talked about.
Yeah.
Now, talking about people's attitudes is a bit psychological. We have to understand their motivations, and it's tricky to do that with regard to individuals. But when one is in the community of people, of scientists, what one has a sense of is that the people in that community, the ones that you can trust, the ones that you have experience with, are the ones that have this sense that it's the world that's ultimately going to give us the answer, and that we have a kind of humility relative to that, not an arrogance that we can actually find the truth, but a kind of optimism that it's there and that ultimately we will make progress in the process of looking for it. And that's why the science community is important. It's not like it's a evil cohort that's preventing new ideas from coming into existence. This is something manipulated by those who feel that they have this grand theory that the rest of the science community isn't paying attention to. It is much more subtle than that. And that's a reason why what's called the scientific consensus is important. Not because the scientists have the absolute answer, but we can trust that the people who have this ethic of looking for the truth of things, that if they are members of the community that does that, that's the best thing we can trust. Because people can always go to sources that claim absolute truth. We are in a crazy political world now where such things are being talked about. That's not science. It is completely different.
But it feels good, It feels good.
Yes, wild ideas feel good, extravagant ideas that
When someone
are,
says they've got all the answers, they've got this model, and this is, and it makes history or prehistory more exciting. It's you can understand why people might like it. Yeah. But I know what you're saying.
there's definitely an appeal, and there's also an appeal, and some scientists, like the late Carl Sagan, tried to convey the wonder of the natural world, the absolute wonder in what nature has to present, which is in many ways much more magnificent than what people can invent. But we're in a terrible state now where people have a misunderstanding of science. They have a misunderstanding that science is this monolithic thing of absolutes, unfortunately manipulated by those that want to claim authority. They claim science as an authority. Einstein once said, all my life I have questioned authority, but in my old age, in punishment for this, I have become an authority. The authority in science is not the people who are saying it. The authority is nature. Nature as the absolute is the absolute. So the truth of one's dedication to searching that in an honest way is the truth that science has to convey. The answers are provisional, but they are trustworthy. And I would say they're more trustworthy than the people who claim authority and claim to speak in absolute terms, even if those are great sounding stories. Human beings love stories. There's something, in the evolutionary genetics of people that has led to their relationship to stories as ways they cope with the world.
Yeah.
That's definitely there.
Speaking of that fallibility
what
thing,
better story is there than what has really happened and what is the case? And that is magnificent.
Right. It's a true story, right? Yeah.
Yeah.
Some people have come to me and talked about how the fallibility of science is a mark against it. Like, well, science has been wrong before. Look they changed their mind about this. You can't trust them.
Well,
but actually,
do you want to trust anybody that claims an absolute authority? Where does that come from? Do they have some special insight into nature? Have they done the hard work of trying to get nature to reveal herself? They make a good story. They make money off of it. They get a claim. All of these they can use logic in their story. They can cite facts in their story. They can cite lots of scientific work. Facts, citing knowledge, that is not science. Unfortunately, in our education system, people are being told that science is a collection of facts. It's a collection of truths about the world, or it's a methodology, a kind of, you pose hypothesis, you do experiment, and you discover the truth because you match your model to the world. The world is consistent with your model, and that's correct. I won't get into it, but there's logical problems in spades with all of that. That is not science by itself. More important than that is this, what I've called fallibilism, which is this honest openness, but incredible hard work, like an incredible detective in figuring out what's going on. Because nature is subtle. Nature isn't sort of advertising her facts. The proper scientist has to work exceedingly hard with many techniques and much modern technology to extract what is really going on and what has really happened.
Nature's not on social media, right?
Oh, no. Social media is propelling stories, and people are looking for the best sounding story.
Yeah.
Well, sounding good is not the same as being good. Being good is what nature presents, and that is what science is really about.
Well, what do you say? What do you say to people who say, "Well, we're just saying keep an open mind. Maybe our idea could be right." And the Graham Hancocks of the world, the Randall Carlsons, that say, "We're just saying keep an open mind. We're just questioning authority. That's all. We're not saying we have absolute truth."
Of course, but if you are going to be a scientist, you want to have a protective, not protective, a productive inquiry into the possibility of finding the truth. Yes, you are open to facts, but you are also not looking at every possibility just because it sounds good. You are looking into things that are leading you on a productive pathway toward truth. If the, and this is very important, science is a process that is trying to productively seek truth. We sometimes talk about our ideas being fruitful. There's an even more obscure word for what we are trying to do. The idea is having a kind of ubrisness to it. This is an old English word. And it is not just that the idea is simply productive, but it's part of a whole line of inquiry that is telling us as we go along that we are on the right path. And that's an attitude that you take. Not that the story sounds good, but that in the process of doing it, you discover things that are leading you more productively along that path. So you have to be open to those discoveries, but you also have to be able to evaluate them relative to whatever is being discovered and has gone before, so that you have a whole body of things that are consistent and leading productively on this path. If you ever think, oh, I have the answer now, it's so wonderful, all these aliens came and did it, and I have all these things, I've been kind of interacting with people telling those stories for a long time. One of the early ones I encountered in my career was Eric von Däniken, who published quite a few books on sort of ancient aliens and how they were coming to the earth in the time of the dinosaurs, and mixing up all kinds of things that geologically we knew were completely inappropriate. But one thing I will say for Däniken is he was very honest. He pointed out that he was writing about these things, but he was an entertainer, that he was doing this to make a good story. I remember one of my paleontology colleagues at University of Texas, where I was many years ago before I was at Arizona. He took me out in the field to look at some of the dinosaur tracks in the Glen Rose Formation, Cretaceous in central Texas, where von Däniken had a picture in his book of human footprints. He claimed human footprints that were along a pathway adjacent to these three-toed dinosaur footprints. Probably a duck-billed dinosaur. They swam in shallow water, and there's other indications in the deposits that this was shallow water. So comparing what Däniken's photograph showed and the footprints, it was very clear what was going on, because the actual marks on the rocks that had been preserved were singular linear traces. They weren't five-toed footprints. What Däniken had done was he had wet the marks so they would be more visible, but he added 5 little dots at the end of them in his picture. Yes, and he would say, well, this is to make the story good. But it's very likely that what was going on is that these three-toed dinosaurs were swimming, and they have a longer toe in the middle, and as they pushed themselves along, one of these would scrape the water bottom, and these would go along a bit, another scrape, just about in the same sort of distance as human footprints would be, and the track had the same distance as human footprints, but it was formed in a completely different way. Now, this is an investigation that you do to figure out what was really going on, and you use all the tools you can to figure that out. It's not about finding things that are consistent with a story that you are trying to tell. That's called sham reasoning, where you know the answer, and you are piling up a lot of good sounding evidences, logical argument, etc., that is going to look like it's consistent with your story. That kind of reasoning is easier to find, as I said, from von Däniken. There's another kind of defect in reasoning that is a little more difficult to deal with, called fake reasoning. This word has been thrown out and used improperly. But fake reasoning is when your motivation, and now we're talking a psychological motivation, is not to find the truth of what nature presents. Your motivation is to make money, to be on podcasts, or to get attention. It's not a scientific motivation. So it's not up to me to know the motivations of the people who are doing this kind of stuff. But one has to be somewhat suspicious that maybe this is a motivation problem. And like von Däniken, if it's entertaining and it's, people can enjoy the story just like a fiction book, there's nothing inherently wrong with that. But it should not be claiming to be science. The claim to be science has to do with the things I've talked about. And unfortunately, what I've been saying about the nature of science, even by many scientists, isn't how they convey it. This is something I've in a very long time, because I probably became a scientist as soon as I was walking and talking, because I was curious about things, and the things I was curious about were rocks. I like, as a kindergartner, I told my parents in Connecticut that I wanted to be a geologist. So it's kind of crazy, but I've had now close to 8 decades of experience with this.
Wow.
And I'm kind of reflecting on it, not just the process, but also my experience with many, many individuals.
So are you saying like some scientists they weren't trained properly? They went to the wrong school, or why are they like this?
They are dedicated to this process of doing science. They would like to be taken seriously. They're human beings like other human beings. And as individuals thinking about it, they have their own motivations as well. They have to have money. They have to, live their life. But as I said, science, an important element of it is not just that these are isolated individuals. They are part of a community, a whole sort of, whole bunch of people that are absolutely dedicated to the same sort of thing. When some of those people get into trouble, like the falsification of data or whatever like that, that community instinctively
they come down on them,
pounces on them, and they suffer.
Yeah.
Science is a very special thing, and so this is why scientists are, it might be said that the scientists are concerned that these people with these ideas like Hancock and others, that they're stepping into the role of scientists, and that scientists don't want them to take over. There may be some that feel that way. I don't. I think they are, they have their motivations, but in terms of what I was saying, they just aren't scientists. They can be like von Däniken, entertainers, purveyors to public interest. in a way, though, they are creating a misrepresentation as to what science really is and what it really is about, and that's a problem that I see.
Yeah.
But it's a bigger problem. It has to do with public understanding, and this gets into the relationship of science to many public issues like climate change and all of the issues that get talked about a lot. There's a huge body of scientific evidence that is not being considered. They're not being fallibilists. They're not thinking seriously that they could be wrong. They may be showing a kind of game of presenting alternatives, acting as though they have considered those. But at least as far as the science community is concerned, there's no indication that they have done that seriously, and therefore they're not going to be taken credibly by the science community. Notice I'm not saying the science community is claiming they have an absolute truth. The absolute truth is in nature itself. All the scientists can claim is that they are absolutely and totally dedicated to this search for the truth, and they are using the best techniques and everything they can to get to it, while also being humble enough to admit that they don't really have the final answer. One could say that this is something we need more of in our society, but it's certainly something that is a part of science. It's something that made me feel that I have always wanted to be a scientist. I just intrinsically, had a kind of affinity toward this whole way of looking at the world.
Yeah. I don't know if this is an area that you study all that much, but do these floods, would they have contributed at all to extinctions of animal species and things like that?
They certainly would have had huge impacts on the local area where they occurred. We have the remnants of carcasses of mammoths that were probably in the flooding, and these are being excavated from flood deposits. So those that were there certainly were impacted, but mammoths were all over North America around the ice sheets, and not all the margins of the ice sheets had catastrophic flooding, nor were the floods all at the same time. In fact, mammoths survived until a few thousand years ago. This is a fact. There were on islands off of Siberia pygmy mammoths that were the relatives of the big mammoths that had existed during the Ice Age. Now, obviously, something happened where most of the mammoths went extinct, but there were probably genetically smaller mammoths that were able to survive in this isolated place. One of the theories that for the extinction, which was developed by a now deceased colleague of mine at the University of Arizona, Paul Martin, was that human hunters who developed advanced technologies at this time that were capable of killing mammoths, the so-called Clovis culture, were a big factor in the extinction of the late Pleistocene megafauna. Now, was a kind of outrageous idea when it was presented, but it was pursued in a very powerful scientific approach. Vance Holliday can tell you more about that because he's very closely involved with it. But it's an example of an idea. When Martin proposed this, it was an outrageous idea that human beings, it created the extinction. But it was a productive idea, regardless of whether it was right or wrong. Pursuing it and looking at it in detail in different places around the world led to new discoveries, some of which were inconsistent with that idea, but others that were. And we do have examples of extinctions. Let's say in Australia, where the ancestors of Aboriginal people arrived, I think they now think about 50,000 years ago. We had massive extinctions of certain marsupials that were readily able to be, accessed by these human hunters, and the animals had never had that before. So there are productive ideas about these issues, and I'm not the person to talk to about the all of the archaeological and geo archaeological evidence. There are others to talk to about that, but the general idea is back to my original point about what is an authentic way of doing science, and that way, which is a little complicated and not as well understood by the general public, is what seems to be at the heart of this problem we have with some of the ideas that are, floating on the internet and getting lots of attention. To me, it's sad because there's much more fascinating and interesting things that do have a close relationship to our approach to understanding the world that could be talked about. Yeah. And would be as interesting as these fanciful, extravagant ideas that I think are motivated by things other than this absolute and true search for the truth.
It's interesting because you'll hear them often complaining that, oh, geologists, they don't believe in catastrophes. They're gradualists. Everything's gradual, but they don't believe in catastrophism. But actually, you're one of the big proponents of cataclysms. You believe in more cataclysms than they do. They want to combine them all into one, right? So
it was a big mistake by some geologists to think they needed a unifying principle for geology. That principle was called uniformitarianism. Even most geologists don't know that uniformitarianism is a word invented by a critic of the idea, a philosopher who understood geology. He invented the word uniformitarianism for this idea that the only processes that we could know about for certain were the ones that we observe today. And today we don't see ice age floods. We don't even see an ice age today. We see a limited sample of what the world is about. The most common planetary surface modifying process in the universe, including in the history of Earth, is impact cratering. It is totally catastrophic. Impact craters are created by processes which can be hundreds or thousands of times more energetic than thermonuclear bombs. Okay? They are more catastrophic than catastrophic floods. That is a common process. The whole surface of the moon is evidence for that, and the moon is as old as the Earth. That happened on the early Earth. So catastrophism, we know there's so much of it that it isn't even an issue. No geologist today would be and I've studied the history of this. There were reasons why geologists embraced this, because they had a kind of a worry that their science didn't seem as absolute and authoritative, and this is a big mistake, as, say, physics. Isaac Newton came along in the 1700s, and he had models that could be absolutely predictive about forces and energy. And one of Newton's ideas was, well, to have this model, we have to be absolutely sure of our assumptions about not just that we have the right equations to figure things out, but we're applying the equation to the right thing. And he had a word from Latin of how we have the right thing. He called it vera causae, that we know the true causes of things. So how can you know the true causes of things? You can do an experiment where you manipulate the causes and you get certain results that are follow from those causes. In geology, do you do an experiment on the whole Earth? Do you do an experiment on a whole river that is flowing from the interior of North America to the ocean, or a glacier that is covering an entire continent? You can't put that in a laboratory and do that. So a very famous geologist, Charles Lyell, said, okay, what can we be certain about? We can be certain if we see it today. Okay, if we see it today, then we can be certain. And the process is we don't see impact craters, we don't see catastrophic floods. So he stupidly, he wasn't stupid, but he made a big logical mistake. And he generalized this to a method to tell geology that they should be doing this. That was highly controversial at the time. And the person, as I said, the guy who invented the word uniformitarianism used it not to ridicule, but to point out the flaws of it. And this is tied to the story of J. Harlan Brett's, which I'm lecturing about now at the university in a program for people from the general public. So
has the pendulum has swung back the other way in more recent times?
Right. No, geologists realized what I have been saying. It's all about what nature presents. And nature is filled with catastrophic processes. So there's no dispute anymore. It's a red herring that is being promulgated by those. Yeah, they can go to old literature and say that geologists are stuck in the mud over this thing, and there have been others who've done this. Emanuel Velikovsky, who was kind of a interesting character.
Yeah.
He promoted catastrophic ideas. He had a fascinating approach where he felt that these things had all been sort of embodied within ancient texts like the Bible. And certainly there's descriptions of things in the Bible that look very catastrophic. And there probably are phenomena that were being described by the sages that were the source of writings. One of my favorites is immense flames that are emerging from the interior of the earth, shooting up into the sky. This is thought, well, there's no examples of this. That has happened. Geologically, we know that flames shot up in the sky from the New Madrid earthquakes in the early 1800s. And there's a completely logical physical reason why these big flames shot up in the sky, because the organic material in the sediments emplaced by the Mississippi River decay and produce a combustible gas called methane. And during the earthquakes, there were explosions of the methane that threw logs into the air and pillars of fire that came out of the ground. So there are phenomena that have actually occurred that lead to descriptions. But the important thing in science is to understand these things, and that requires using the best techniques we can to see how nature brings certain things about. So it's not about the initial explanation. It is about the investigation and the absolute dedication to honestly investigate that problem, which is not what these people do. They, as I said, I'm not the one to judge, but it certainly has the appearance of a lot of fake and sham reasoning that is motivated by something different than what I've been talking about, which I think is intrinsic to science. Notice that I am not being a skeptic. if things are noticed that are odd and are not explained, there is possibility of doing important science on that. These are called anomalies, and they are absolutely critical to doing science. But just to say that science is not, is skeptical about this, that's not an appropriate thing. If they are worth pursuing, some scientists will pursue them. And as in the case of J. Harlan Bretz and the Channel Scabland, the science community will come to the conclusion that he was absolutely correct. It may take a little while, that tools may have to be developed to do this, but it will definitely come into play. Mm-hmm. So it's a much more subtle and interesting, in some ways, line between this non-science that has to do with attitude and real science. Much more subtle and interesting than how the public thinks of it as science as authority.
Mm-hmm. So the verdict on the Scablands is that, much as is the case with the purported evidence for an impact, there is no synchronicity. There were catastrophic floods, all right, but these floods simply do not line up in time so that they can be referred to as a universal catastrophe, not even in North America. Now, I just want to address a possible objection that impact proponents might have about synchronicity, which we touched on earlier. Recently, they have fallen back to a position that asserts synchronicity is not necessary if we assume that the catastrophe was prolonged. Maybe there was an extended series of events, and in such a case, things don't need to line up exactly. But all that really does is water down the hypothesis to make it less falsifiable. The more nebulous your proposal, the easier it is to get the evidence to fit into it. It seems like a cheat, but at the very least, it makes the hypothesis less clear, specific, and testable, which is what all hypotheses should be. And this watered-down hypothesis, unfortunately, is not great for lost civilization proponents, because it makes the complete destruction of a continent-spanning advanced civilization less likely. So where does that leave us? Well, the impression I get overall is that the people who are advocating for a younger Dryas comet impact and an accompanying worldwide catastrophe that resulted in the extinction of megafauna and human populations simply don't have the necessary supporting evidence to put any faith in it. Is it possible that more evidence will be forthcoming and that these researchers will one day be vindicated? If that happens, I am more than willing to accept it, but it does seem unlikely from what I have gathered. Anyone who truly believes in science and the scientific method would never believe in something until after sufficient evidence was gathered. If you already believe in it, ask yourself why. And even if the impact, however unlikely, ultimately gets proven, it's a whole different enterprise altogether to argue that this event wiped out an advanced continent-spanning civilization. For anyone to believe that, you would need to find evidence for the civilization, and that would require more than just going around the world pointing at artifacts attributed to other civilizations and claiming that they are actually from this advanced civilization on the basis of the argument that, in your opinion, the known civilizations were too primitive to have produced them. Thank you for watching all the way to the end. If you like this video, please give it a thumbs up. And if you like this channel and want to support what it is doing, consider becoming a patron by going to patreon.com/World of Antiquity. Or you could give a one-time donation as a super thanks right here. You might like my little e-booklet, Why Ancient History Matters. It's designed to persuade people that the subject is important, even in the modern world. You might also wish to use it to help spread the word. So feel free to share it with someone you know. It's free for anyone who wants it. I've left a link in the description box below the video for you to grab a copy. Catch you later.